Big history is a concept that integrates knowledge from the natural and social sciences with the humanities. The result is a more realistic understanding of how humans fit into the vast expanse of the universe. As part of this survey, we will consider some of the challenges of modern globalization, with an important theme being the quest to develop sustainable and ethical lifestyles. The overall focus of this course will be about what such knowledge might mean in our everyday lives, and how we should, as responsible individuals and as a responsible species, conduct ourselves in this world. This is Michael Morrison.
Could you tell us a little bit about yourself and how you fit in with big history?
I was the climate scientist for the Greenland Ice Sheet Project in the early 1990s. We drilled a 2-mile ice core out of the Greenland ice sheet. Got 100,000 years of climate history, detailed, continuous. An exceptional project. It actually is the one that has really given us our modern picture of how recent climate works and even an understanding into climate. Before that project, we had a sense of climate changing gradually over thousands or tens of thousands of years. And what we discovered in this core was that in fact climate changes quite rapidly in many instances in less than a decade from glacial to interglacial conditions. So we came to understand sort of a very dynamic, rapidly changing climate system, and also came to understand many of the parts that are involved: atmospheric circulation, atmospheric composition, the chemistry of the atmosphere. Carbon dioxide, methane are important members. Oceanic circulation, biological activity, any number of pieces. So we've really got our modern picture of how climate works from this core. I have since been working on the educational dimension, which we know that there's more research that we should be doing about climate. There's more that we need to learn and should be pursuing. But in recent years, the issue is not, do we know enough? We do know enough now to know what we need to do. The question is, can we bring that forward to the world as a whole, sort of the educational component, so that folks understand where we are and what's at stake. So I've been working more on that recently. I've done training with Al Gore for to give presentations, which I did with Barry's class, and work on organizations and so on, and try to integrate it also with my profession. Well, where we are, in my opinion, and sort of taking this big history view that you're presenting here, is that the Earth is actually a very dynamic, even we could call it a violent place. The temperature swings that we've seen just create havoc for the critters that live here. Life has survived that in varying degrees, even exceptional degrees. You know, 65 million years ago there was a meteorite that caught the whole world on fire in a matter of hours. So it's a really dramatic thing. So life has continued, and we can pretty much expect that life is going to continue no matter what we do.
Just not in this form, maybe.
Yeah, there will be a lot of, there already are, and there will be a lot of extinctions. We are the authors, the agent giving rise to the current mass extinction. There have been a number of them that we know of historically. We are in the midst of another one, and we are the agents of this one. The thing that I think that we need to understand is that that life on Earth is not at stake in the big sense of the picture. What's at stake is civilization. Civilization emerged in the last 12,000 years, which we now know has been a remarkably stable period of climate. When we look at the last 100,000 years of climate, we see temperature swings of 5, 6, 7, 8, 9 degrees centigrade, back and forth, even across periods of decade or less, every 1,000 or 2,000 years. And the last 12,000 years, we've been plus or minus a degree, you know, just like there's a flat line, you know, and that stability, that relative stability, is what has made it possible for civilization to emerge, and we depend on that.
Are we approaching a threshold now with that stability?
Well, we can expect that all on its own, even without us, even without our activity, we would again return to dramatic
Okay.
changes. There's no reason to suspect that it wouldn't. But what we know now is that our activities are precipitating one now. We are the authors of this one.
Right.
So roughly speaking, carbon dioxide is the primary control on climate. There are many events that are important in triggering climate change, and it's clear now that changes in orbital parameters are the main ones historically, at least in the last few 100,000 years.
Yep.
It changes the amount of sunlight that reaches the northern hemisphere, which is where all the trees and plants are. That's where all the land is, by a little bit, and those changes give rise to changes in carbon dioxide, which in turn give rise to changes in climate. It's not the actual change in the sunlight that actually is enough to change the climate. It's what it does to the plants that gives rise to the change in climate.
Right.
So we know this. This is a pretty well understood story now. There's always more details, always more that we can learn. But we know the big picture here. During those swings, average temperature on the Earth has gone up and down 5 or 6 degrees centigrade. And that has been the result of changes in carbon dioxide going from about 180 to 280 parts per million. We're at 387 today, and that's all. We've gone from 280, which is where we've been for about the last 12,000 years, to 380, 90 parts per million in the last 150 years.
So this is a real rapid change.
This is extraordinarily rapid.
Is it faster than it's happened previously in
Much
history?
faster.